Okay, we're done with this. Because size of molecule increases, so flammability decreases, and melting boiling points increase, and viscosity increases. Now we're going to discuss the individual homologous series and their physical and chemical properties. Now, one of them is starting with alkanes and alkenes. So, alkanes and alkenes, they kind of have very similar properties, similar physical properties, not chemical. So, what kind of physical properties are similar? A few of them. For example, they would have pretty much the same low melting and boiling points usually compared to other organic compounds. They're definitely not soluble in water. I mean, so for example, if you have petrol and you try to mix it in water, it's not going to mix. If you have methane gas, you try to absorb it in water, it's not going to get absorbed in water. So they're not soluble in water, but they are soluble in organic solvents. Like if you mix them in kerosene, then they're going to dissolve. One example is, I mean, you have oil paints and you have water paints. Oil and water, they don't really mix with each other. Uh, Substances that are organic, they're usually soluble in oil. Substances that are uh, polar, they are more soluble in water. I said now alkanes and alkenes can remember this one, that they're not soluble in water, but they're soluble in organic solvents. The third one is that they're not going to conduct no electrical conductivity, and that's pretty much about it. Okay, so remember alkanes and alkenes, but also remember this thing, that if the molecule becomes bigger and bigger, though the melting and boiling points would increase. Um, and I'll add a few more points to this. As the molecule becomes bigger, solubility also decreases. They become less and less soluble. Now, alkanes and alkenes have similar physical properties, and similarly, alcohols and carboxylic acids, they kind of have similar physical properties. Now, in the relative sense, they have what they have is they have high melting and boiling points. If you're comparing it with high melting and boiling points, if you're comparing it with these alkanes and alkenes, and they're soluble in water actually, and they're very soluble in water. One example is vinegar. Vinegar is acetic acid or ethanoic acid, and it dissolves in water very easily. So it's soluble in water, and uh, and they're usually not soluble in organic solvents. So then there's another point which is about electrical conductivity. उसके अंदर there's going to be a slight difference. Alcohols are covalent molecules, but they don't conduct. I mean, no covalent molecule conducts electricity because they don't have any charged particles. If I draw a molecule of alcohol, there are no charges. For example, there's an alcohol, this is ethanol. So there is absolutely no charged particle. They're all sharing electrons. No one is losing or gaining electrons. So there are no free moving electrons or ions. Nothing. Achha, but and the same is almost true for carboxylic acids, but carboxylic acids are weak conductors, and you would call them electrolytes. So why are they weak conductors? Because remember, like HCl, like acids, some molecules are covalent, but they react with water. So they're weak electrolytes when aqueous. Okay, when they are aqueous, when they are mixed in water, they become weak electrolytes. What happens to them is that if you have an ethanoic acid molecule or any acid, and you have a molecule, and if it's aqueous, it eventually ends up reacting or bumping into water molecules, and the H at the end breaks away. And when it breaks away, ions are formed. So they weakly, very weakly, not all molecules. Like if you have 1,000 molecules, then one of the ethanoic acid molecule might bump into water molecules and might dissociate and ionize, and it would produce ethanoate ions and H plus one. So they weakly ionize, or you can call it dissociate. So they don't produce a lot of ions. Few ions are produced, which can carry charge, which can move around. So charges can be moving. I mean, electricity is moving charges. So few ions are produced. Hence, it's a weak conductor. So it's a very weak conductor. So carboxylic acids, remember, they're very terrible conductors, but they do conduct. If there's a bulb, it's going to light up, and but it's not going to light up very brightly. So alcohol and carboxylic acids, they were very similar, except for this last point that carboxylic acids are actually conducting electricity. Now, moving to the next part, we will now start discussing. We're done with the properties. The next part we're going to talk about is the reactions. So, reactions. Now, the first one is this applies to all compounds, all organic compounds. Okay, so almost all organic compounds. Remember, bigger molecules. I told you already that if you have a size of molecule increases, the flammability decreases. So if it's a bigger molecule, it's harder to burn. But if you want to burn it, it's going you can burn it, okay, but it's going to be more difficult. Like candle wax, it's harder to burn candle wax. So the first reaction that we're going to talk about is combustion. All organic compounds, they're going to combust. So, and they pretty much combust in almost the same way. For example, I have a molecule of ethene, which is C2H4. So I'm going to react it with oxygen, and two products are going to be produced. One is going to be carbon dioxide, and the other one is going to be water. So this is one example. An ethene molecule. So an ethene molecule burns up and ends up producing carbon dioxide and water. And you just need to balance this equation. So there are two carbons over here. There should be two carbons on the right side. There are four hydrogens over here. There should be four hydrogens on the other side. In total, you have how many oxygens? You have four plus. You have four over here and two over here. So that's six. So I'm going to multiply this by three. So all organic compounds, they are going to combust. There's going to be complete combustion, and complete combustion happens when there is excess oxygen. Okay, that's when complete combustion would happen. And simultaneously, there's going to be incomplete combustion is also possible. That is going to happen when there's a limited. So when there's a limited supply of oxygen, that's when incomplete combustion happens. And now the thing with incomplete combustion is they're going to be additional products. Additional pollutants are going to be produced. Your additional products are going to be carbon monoxide, uh, carbon, which is soot, that could also be produced. And I told you carbon monoxide is a poisonous gas. It causes choking. Carbon dioxide is also not a good gas. It's going to produce a greenhouse effect, which is it causes global warming. So that's the first reaction. I said I'm going to expect you to make these equations, like combustion equations for any organic compound that I talk about. So I'm going to write down the reactions. Sorry, the formulas. What was the general formula of an alkane? It was CnH2n plus 2. Okay, so you can figure out the formula of any alkane. Like if you want to figure out the formula of propane, you need to know that prop is three carbon atoms. I mean, I'll write down the counting over here as well. It's going to be eth. Meth is one, eth is two. Then you have prop, and you have bute and pent and hex and hept. Okay, so you have all of this. उसके बाद hept के बाद there was oct, non, and there was dec as well. 10 tak, that's counting. As anyway, so this is the formula of alkane. Butane, that's four carbon atoms, so it's 4 into 2, 8, 8 plus 2, 10. As I'm going to write down the formulas of all the other ones as well. It's you have alkenes. Their general formula is CnH2n. Then you have alcohols. Now for alcohols, the general formula is CnH2n plus 1 and OH. And finally, the last one is carboxylic acid. Its general formula is CnH2n plus 1 COOH. Okay, so you have all these general formulas. Remember, we did carboxylic acids, and we did all of them. How did we make carboxylic acid? I told you that in carboxylic acid, you have the number of carbon atoms. That's your prefix, eth, prop, bute, etc. You just have to add this. Uh, but you can also use the general formula, which is like if I want to make propanoic acid would be three carbon atoms, right? So propanoic acid would be three carbon atoms. So it's going to be 1, 2, 3, double bond O and OH. I mean, that's the functional group of propanoic acid. And I'm going to put in the hydrogens. Or I could have used the general formula. अच्छा इसका ख्याल रखना कि in this case the general formula in the case of carboxylic acids only N is one less than the number of carbon atoms. Like if propanoic acid has three carbon atoms, in the formula, if you're using the formula, you're going to use N equal to 2. Okay, it's always going to be one less. So if we do a close-up and if I take N is equal to 2, so what would it be? It would be 2. Then 2 into 2 is 4, 4 plus 1 is 5. So it's going to be C2H5. And then it's going to be C double bond O and H. Okay, that's going to be the I mean that these two are exactly the same. So remember this, make sure you know this point that when you're using the general formula of carboxylic acid, N is not the number of carbon atoms. N is actually one less than the number of carbon atoms. So if it's propanoic acid, you're not going to use N is equal to 3. You're going to use N is equal to 2. क्योंकि वो एक कार्बन पहले ही है ना, तो I mean if you include this carbon atom and the 3 carbon atoms, so one is over here, you just need 2 over here. So इसलिए N is one less than the number of carbon atoms. Now these two are exactly the same thing. Compressed formula, this is written as COOH. CO and OH. CO and OH. So the compressed notation of this is COOH. अच्छा खैर, these are the general formulas. I just told you करना ये कि you have to write balanced equations for combustion of a particular organic compound. So I'm going to give you a name. Let's say I tell you ethanol, and I tell you to write the equation for the combustion of ethanol. So how do you figure out ethanol? Eth has 2 carbon atoms, so that's C2, and H would be 2 into 2 is 4, 4 plus 1 is 5, so it's going to be C2H5. OH, and I have asked for the complete combustion equation for this ethanol molecule. So every time it's going to be CO2 and H2O that are going to be produced, and we can balance it. So it's going to be 2 carbon atoms, and there would be 3 hydrogens, and the total number of oxygens are 7 over here. So एक पहले है वहाँ पे, so I just need 6 oxygens over here. So this is going to be 3O2. So that's going to be the entire. So that's going to be the entire equation in this case. ये clear है सारों को? Anna, is this clear? It.
Yes.
अच्छा, so I mean this is what you're going to do now. ठीक है, तो I'm going to write down the names. सारी चीज़ें मेरे ख्याल से मैंने the screen के ऊपर ही लिख दी हैं. So I'm just going to write down the name, and you have to write a balanced complete combustion equation for them. So let's talk about propene की लिखो. So number 3 is butanol. The number 4 is write a combustion equation for heptane. 5 questions there. And number 5 is pentanoic acid. So you have 10 minutes for this. Give me 5 complete balanced combustion equations of these 5 molecules. Separate है सारे. फर्स्ट वन हो जाए तो वो मुझे सेंड कर दो.